Our next topic in Unit 1.2 is concept of primary and secondary transmission and distribution. The large network of conductors between the power station and consumers can be broadly divided into two parts, that is, transmission system and distribution system. Each part can be further subdivided into two sections. The first part into primary transmission and secondary transmission, and the second part into primary distribution and secondary distribution. The GS represents the generating station, where electric power is produced by three-phase alternators operating in parallel. The usual generation voltage is 11 kV or 16 kV. For economy in the transmission of electric power, the generating voltage, that is 11 kV or 16 kV, is stepped up to 132 kV or more, like 200 kV or even 400 kV at the generating station with the help of a three-phase transformer. This transformer is known as generating transformer. The transmission of electric power at high voltages has several advantages, including the saving of conductor material and high transmission efficiency. It may appear advisable to use the highest possible voltage for transmission of electric power to save conductor material and have other advantages. But there is a limit to which this voltage can be increased. It is because increased in transmission voltage introduces insulation problem, as well as the cost of switchgear and transformer equipment is increased. Therefore, the choice of proper transmission voltage is essentially a question of economics. The electric power at 132 kV is transmitted by three-phase, three-wire overhead system to the outskirts of the city. These form the primary transmission. The primary transmission line terminates at the receiving station, which is usually lies at the outskirts of the city. At the receiving station, the voltage is reduced to 33 kV by step-down transformer. From this station, electric power is transmitted at 33 kV by three-phase, three-wire overhead system to various substations located at the strategic point in the city. This forms the secondary transmission. The secondary transmission line terminates at the substation, where voltage is reduced from 33 kV to 11 kV three-phase, three-wire. The 11 kV line runs along the important roadside of the city. This forms the primary distribution. It may be noted that big consumers having demand more than 50 kW are generally supplied power at 11 kV for further handling with their own substation, and they are known as high tension or HT consumers. The electric power from primary distribution line, that is 11 kV, is delivered to the distribution transformer, mostly pole mounted. These distribution transformers are located near the consumer's localities and step down the voltage to 400 volt, three-phase, four-wire for secondary distribution. The voltage between any two phases is 400 volt and between any phase and neutral is 230 volt. The single-phase residential lighting load is connected between any one phase and neutral, whereas three-phase 400 volt motor load is connected across three-phase lines directly.